All right, welcome back to Algebra 2. This is target 24. I can evaluate a logarithm in any base. All right, first of all, we need to talk about what is a logarithm. So I want you to first think about what the powers of 2 are. So if you take 2 to the 0 power, it's equal to 1. Okay, 2 to the first power is equal to 2. 2 to the second power is equal to 4. 2 to the third power is equal to 8. 2 to the fourth is 16. 2 to the fifth is 32. 2 to the sixth is 64, okay, and so on. Right, now, what a logarithm then is it's basically the opposite of a power, of an exponent. So when we talk about a logarithm, what we're talking about is what we're answering the question. Okay, we're answering the question, to what power do I need to raise a base to get a certain value? So for example, if I wanted to say to what base or what power do I need to raise 2 to get 256? Right? So if I want to know what power of 2 is equal to 256, if I look at this table over here, I can pretty easily see that 256 is equal to the 8th power. So it's the 8th power of 2 that's equal to 256. Now, in terms of a logarithm then, what we would write, okay, is log base 2 of 256 is equal to 8, right? It's telling us what power. Okay, and this is one thing that I tell students all the time is that the definition of a logarithm really is that it's whatever the power is. Okay, a log is equal to a power, and you can see that here. The log is equal to the power. Right, it's the 8th power of 2 is 256. All right, so our formal definition, okay, of a logarithm with base b, okay, is that the log base b of y is equal to x, okay, if and only if b to the x is equal to y. All right, so you can see b is always the base. Okay, it's either the base of the logarithm right here, okay, or it's the base of the exponential expression over here. Right, x is the exponent. Right? So in an exponential expression, x is in the exponent. In a logarithmic equation, x is what the log is equal to. Right? That's what I said before. A log is equal to the exponent. Okay, and then y is the value. Right? Y is this value that of the logarithm. So the way we read this, okay, again, this is different notation than probably what you're used to, okay, but it's just read as the log base b of y. So if I have this, okay, I would read that as the log base 3 of 27. Right, and again, what am I asking when I ask for the log base 3 of 27? I'm saying to what power of 3 is equal to 27? Right, that's what a logarithm is. All right, so evaluating logarithms, there's two main types of logarithms that are really easy to evaluate. Okay, and the reason they're really easy to evaluate is because we can do it using the calculator. All right, now, why are these two logarithms on our calculator and none of the other ones are? Well, these two are called the common logarithm, okay, and the natural logarithm. So a common logarithm is a logarithm with base 10. So why is base 10 so common? Well, think about how we count. We count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then start over. 11, 12, 13, 14, 15, 16, right, up to 20, and then 21, 22, 23, right? It's always in groups of 10 because our counting system, right, the number system that we work in is called the decimal system, which is base 10. So that's why that's the common logarithm. The natural logarithm comes right from what we studied in target 23, which is base e, right, the natural base. Okay, so a natural base logarithm is a base e logarithm. Okay, log base e of x, okay, we write just as ln, right, which is natural logarithm. And why it's ln and not nl, not exactly sure, but we write it as ln of x. Right? So most calculators, okay, have keys for the common, right, which again is just log, right? We don't put it with any base, we just write log x, okay, and natural log, which is ln. All right. Now, if we have a logarithm with a base other than 10 or e, we can use something called the change of base formula. So change of base formula says that if you have the log base c of a, right, you can rewrite it as the log base b of a divided by the log base b of c. Right? So notice how the base, okay, ends up in the bottom. Right? So base goes in the bottom of the fraction. Okay, and that's how I tell students to remember this change of base formula, is that it's just log base, whatever base you want, and then, right, what you were taking the log of over here, okay, stays on the top, okay, and then what base you were using originally, okay, now goes, you take the log base b of that in the bottom of the fraction. Now, what bases help us are the common log and the natural log. So in particular, okay, what we want to do is use common log of a over common log of c, or natural log of a over natural log of c. Okay, and this is what we call the change of base formula, and this is what allows us to find or evaluate a logarithm in any base, not just a base 10 or base e. All right, so let's evaluate each one of these logarithms. Okay, here, the first one we have log base 4 of 7. So again, what we're looking for is 4 to what power is equal to 7. Okay, that's what we're trying to figure out. So to find log base 4 of 7, that's not a common log or a natural log, so we're going to use the change of base. So we're going to rewrite log base 4 of 7 as, and let's use the common log. Okay, so common log of 7 divided by common log of 4. Now, to find out what that's approximately equal to, we can use our calculators. So let's clear this so you can see what I'm typing. All right, so log base 4 of 7. So we want to do the common log. So the common log button is right over here next to the 7. And we want to find the common log of 7, okay, divided by the common log of 4. So we type it in that way, press enter, and we get 1.403677461. So it's about 1.4. Now, if we go back up to the original question, right, okay, 4 to the x equals 7, 4 to what power is equal to 7? If we check our answer, right, we can always check our answers here. We do 4 to the 1.4 power, okay, does that equal 7? Well, let's try it with our calculator again. So now remember, we rounded, right, it wasn't exactly 1.4, we rounded that off. But if we do 4 to the power of 1.4, we come up with 6.96. So if we round that, that's equal to 7. So it doesn't come out exactly right, but we can tell that we must be on the right track because it does approximately equal 7. So this isn't exactly equal to 7, but it's approximately equal to 7. All right, let's try the next one. So if you are following along at home, why don't you pause the video and try the second one, and then restart it when you're ready. All right, so log base 5 of 13. Again, if we rewrite it, we're looking at log base 5 of 13 to be equal to log, well, again, we can choose the base we want to use. We used common log last time. Let's try natural log this time. So if we do the natural log of 13 divided by the natural log of 5. Calculate that. Natural log 13 divided by natural log of 5. And we get about 1.6. Now, the great thing is here, since I didn't use natural logs last time, if you tried this and used common logs, you should have gotten the same thing, right? If we go back and use common logs, if you do the common log of 13 divided by the common log of 5, you should get exactly the same answer, right? 1.593692641. It's exactly the same. So it does not matter if you use common logs or natural logs. And again, you could use any base you want, but we use natural logs and common logs because we have buttons for them, right? We have buttons for them here on our calculator, right? Log and ln. So that's the ones that are going to be easiest to use. All right. Okay, 2 more examples. Okay, why don't you go ahead and work those out on your own, and pause the video, and then when you're ready, restart. Okay, so let's zip through these last 2 examples really quickly. All right, first one, log base 3 of 15 is going to be log of 15 over log of 3. Okay, and this last one will be log of 22 divided by log of 8. So if we calculate those, all right, log of 15 divided by log of 3 is about 2.5, and then log of 22 divided by log of 8 is about 1.5. All right, so those are the last 2 answers, about 2.5 and about 1.5. All right, so to wrap up here, okay, summary, okay, a logarithm, first of all, the definition of it is the opposite of an exponent. Okay, both use bases. Okay, the key point here, the definition of a logarithm is that the log base b of y is equal to x, okay, if and only if, right? So you can really go back and forth between these 2 things, these 2 expressions, log base b of y equals x, and b to the x equals y. So if you have this type of expression, you can rewrite it as that, okay, or vice versa. Okay, this definition goes both directions. All right, and then secondly, evaluating logarithms, the key idea in this target is that we use the common base and the natural base, okay, logarithm functions of your calculator, okay, along with the change of base formula to evaluate any logarithm. And again, that change of base formula, okay, is log base a of c is equal to the log base b of c divided by log base b of a. Okay. And again, more specifically, we're going to use just the common log of c over the common log of a, or the natural log of c divided by the natural log of a.